All right, for our next piece, I'd like to take a look at just the regression equation. So we've been going through this process of making a scatter plot, finding a trend line, estimating the correlation coefficient value, and then we took a look at how to do all of that using Desmos, our technology, because Desmos can find the actual values. When we do things by hand, we can't find those actual values. So what you did yesterday was use Desmos to find the regression equation. And just a reminder that that's the equation of the trend line. And we find that using this linear regression process. So when you are using Desmos and you enter your data into a table, we end up typing this code into the calculator. Okay, when you type that code into the calculator, what it does is it gives you these different statistics and parameters down below. Okay, so for the statistics, the R value is the one that just says R equals 0.9913 in this example. The R to the second power, the R squared, that's just a different type of number used for a different analysis. Okay, so we are using just the R value here anytime we're looking for the actual correlation coefficient. Okay, so we don't really care about this one. Now, for the parameters give us the slope of the trend line and the y-intercept of a trend line. Remember our equation, y equals mx plus b? Well, that's the slope-intercept form of an equation. Okay, so we're going to take those numbers, the m, and plug that in front of the x. And we're going to take the value of b and plug that in at the end. That's your regression equation. That's the equation that we can use to make predictions about the two variables. All right, so that's what we're going to take a look at today, is just focus on the regression equation and practice working with it. Here's our first example. Okay, we don't really know anything about the variables. This is just straight up equations and numbers. Okay, so this is more of the skill based on what we're going to do. So number one says to use the regression equation to solve for the missing variable. And we have our equation there, y equals 0.34 times x plus 7.1. All right, so we're going to use this equation two different ways. In the first one, part A says if x equals 10, then y equals blank. Okay, in other words, if we know the x value, let's use the equation to solve for y. Okay, so I copied that equation down below in red. Y equals 0.34 times x plus 7.1. And if we know that x is 10, we can replace x with a value of 10. All right, from there, it's just a matter of doing a little calculator work. There we go, multiplied by 10, should be 3.4. And then we want to add 7.1. Yes, that is correct. 3.4 plus 7.1. Sorry about the calculator. So we end up with 10.5 as a y value. So I'm just going to record that down below here. And we got 10.5 is the y value. So x equals 10, y equals 10.5. All right, so that's one way. If we're just given the x value, we can use it to solve for y. Now in the second example, we're going to take the same equation, and this time we're going to take a given y value and try to use that to solve for x. So in our equation, I don't want to put 14.92 in the place of x because it doesn't equal x. 14.92 is the value of y. I'm going to replace that. Replace the y in the equation with that number. And now I have to do a little solving. I have to work backwards to try to get x by itself. So the first thing I want to do is subtract 7.1 from both sides. And that's going to leave me with 7.82. And I'm going to bring down the 0.34x. And of course, 7.1 minus 7.1 is 0. All right, so now to finish solving for x, we divide by 0.34 on both sides. And we will get, let's see, I better check on a calculator with this one. Hopefully I can type this correctly this time. 7.82 divided by 0.34 is 23. So if y equals 14.92, we use that value to solve for x, and we got x was 23. All right, so that's two ways that we can use that equation. We can use the value of x to solve for y, or we can use the value of y to solve for x. Let's look at a problem where we have some actual application, where it makes a little bit more sense to us for our x and our y. All right, so here we have the baseball team sold bags of water softener salt as a fundraiser. The boosters wanted to see if there's a relationship between the number of bags sold, which is x, and the amount raised, which is y, by each player. They found the relationship could be modeled by the equation y equals 7.6x plus 16.9. So x is the number of bags that were sold, and then y is the amount that was raised. Okay, so we have our variables already defined for us. Just a reminder that the dependent variable is the y variable. So the dependent variable is the amount raised. The independent variable is always x. That's the number of bags sold. So question A, if a player sells 65 bags of salt, how much money can they expect to raise? So in that question, they're giving us the value of x because they're telling us it's 65 bags of salt that they sell. So that would be the number of bags sold. So they're kind of telling us x equals 65. And it says how much money can they expect to raise? Well, that's the y value, the amount raised. So they want us to try to figure out what does y equal. All right. So if x equals 65 in our equation, we're supposed to use that to solve for y. So let's take our equation. Y equals 7.6 times x plus 16.9. We now know that x is 65 bags of salt. I'll go ahead and replace x with 65. Then I have to do a little calculator work. I have to multiply first. 7.6 times 65 bags of salt. That's going to be $494. Well, that's not my final answer. I still have to add the 16.9 to get a total. So 494 plus 16.9. 510.9. Now, that's the answer to the equation that we saw. 510.9 is the value for y. But we need to make sure that we're answering the question. It said, if a player sells 65 bags of salt, how much money can they expect to raise? So our answer here needs to be written in terms of money, like dollars and cents. So I would actually want to say that yes, it's $510, but then because there's a 9 after the decimal point, that's not 9 cents, it's 90 cents. So that player would expect to raise about $510.90 if they sold 65 bags of salt. Again, that's just based on the trend that we got from our regression equation. Now, for question B, it says if a player wants to raise $1,000, how many bags of salt can they expect to sell? So this time they're giving us the value of y. They're saying the amount raised would be $1,000. And what we need to do is try to figure out what does x equal then when y equals 1,000. In other words, how many bags of salt could be sold to raise $1,000. So we take our same equation, 7.6 times x plus 16.9, and we are going to replace what we know. And in this equation, we know that the y value has to be $1,000, and then we solve. So we use our equation solving, subtract 16.9 from each side. And let's see, I want to be careful of that. 1,000 minus 16.9 should be 983.1. And then finally, to get x by itself, we just need to divide by 7.6 on each side. Just solving two-step equations here with this slope-intercept form. All right, and I still have that 983.1 number in there, so I just need to divide by 7.6. And I get 129.355263. Okay. I am going to round that a little bit because with this real life meaning or application, I know it's not going to include all those digits. So let's think about this. How many bags of salt will they need to sell? Okay, so we're going to want to, because we're not going to say, oh, 129.355263 bags of salt. We need to round appropriately. So in this case, we look like we're going to round to the nearest whole bag of salt, which, because that 3 is after the decimal, that's telling us to round down. So we're going to leave it as 129 bags of salt. And we could even use like a little squiggly equal to say it's not exactly equal, but it's approximately that. So 129. All right. So what I'd like you to do is go check out the homework assignment today, posted in Schoology, a couple different examples like this. Make sure that you are rounding things appropriately. If it doesn't make sense to have decimals, then round to the nearest whole number. If you are working with money, for example, where it would make sense to have decimals, make sure that you're rounding to the nearest cent or nearest penny in a case like that and write your answers accordingly.